So graphing quadratics up until now, we've had to make this table, and it's been really cumbersome, right, to graph quadratics. So instead of picking values to substitute, we're still going to do that a little bit, but we're going to use some tricks of the trade. We're going to make it easier for us to graph. So to graph quadratics, we're going to follow these rules. So the first thing we're going to do is we're going to find the axis of symmetry. We're going to find the axis of symmetry, which we talked about previously, right? Axis of symmetry, how do you find the axis of symmetry? Zach?
You do like the negative b over like 2a, and then after you do the x, and then you find the y with substituting the x in the equation.
Axis of symmetry is negative b over 2a. And remember, we do a dashed line when we do it, right? The axis of symmetry is our flipping point. We can reflect. If something's 2 spaces to the left, it's going to be 2 spaces to the right of the axis of symmetry. I mean, the axis of symmetry cuts our work in half. It's great. After you find the axis of symmetry, you're right, Zach, you take it a step further and you find the vertex. And the steps for finding the vertex, you substitute the AOS. What's AOS? Axis of symmetry. Into the problem or equation and solve for y. So when you substitute the axis of symmetry into the problem, you do the math, you type in your calculator, right? Whenever you substitute, what should you always use? Parentheses. So you do all this work, you substitute, you get an answer. Now you have an ordered pair, right? Ordered pair is the vertex. So first we find the axis of symmetry, we make that dotted line. The dotted line is going to help us out because we reflect over it, the axis of symmetry. It's symmetrical on both sides. After we find our axis of symmetry, then we find our vertex, which is just taking the axis of symmetry one more step. Substitute the axis of symmetry, that x value, into the original problem and solve, and you get an ordered pair. That's either the minimum or the maximum, right? It's the top or the bottom of the graph. Can you reflect the vertex? No. Why can you not reflect the vertex? Where's the vertex located? What is the vertex? It's the turning point, right? So the turning point is on the axis of symmetry. So if something's smack dab in the middle, can it be reflected? No. So we can't reflect yet, but now we can. After you find your vertex, then you can reflect. You're going to plot the y-intercept. Remember when we were graphing linear equations, we always started at the y-intercept? If you had y equals 1/2 x minus 4, where would that graph start? At -4. That's our y-intercept. You'd go down 4 and put a dot, right? In a quadratic, there's a y-intercept. Ladies and gentlemen, the y-intercept is always your constant. So in the quadratic, y equals x squared minus 8x plus 2. What's the y-intercept? Plus 2. In the quadratic, 3x squared plus 7x, what's the intercept? The constant is your y-intercept. And once you plot the y-intercept, you can reflect it. Yeah. Flip it over. Count how far away it is. Sometimes the y-intercept's too big to graph. It won't fit on your graph, sorry. Right? If it says -20, do you really want to extend your graph to -20?
Yeah. Yes.
You're crazy.
Yep.
And then we only have to do this. If you can plot the y-intercept, you only have to go to step 4. Choose an x value one space away from the axis of symmetry. So if your axis of symmetry is 3, what could you choose? 2 or 4. If your axis of symmetry was 0, what could you choose? -1 or +1. Doesn't matter which one. Typically go for the positive just because negatives sometimes screw us up, right? Yeah. But I mean, if you have to pick a negative, you have to pick a negative. Yeah. Choose an axis or an x value one space away from the axis of symmetry. And substitute it into the original equation. And get an ordered pair. Here's my disclaimer, right? You have to have 3 ordered pairs. Okay? You have to have 3 ordered pairs. The first ordered pair is going to be your vertex, right? Second ordered pair is going to be your y-intercept, correct? The third ordered pair is going to be this x value one space away from the axis of symmetry. But sometimes your vertex and your y-intercept are the same. Or sometimes your y-intercept and the x value one space away are the same. You have to have 3 points on your graph in order to reflect, okay? If you need a third point, repeat step 4, but choose an x value 2. spaces away from the AOS. Sometimes your vertex is already your y-intercept, or sometimes your y-intercept is one space away from the axis of symmetry. Sometimes that happens. You cannot stop with your vertex in one point. You have to have three. Because step 5 is reflect and connect. All right, we got root. Ready? Y equals x squared minus 4x minus 5. I'm not going to glue this down yet. Right? I'm going to give myself some time to work. Ready? All right. Step 1, find the axis of symmetry. Negative b over 2a. So negative what? What's my b value? Negative 4 over 2. What's my a value? 1. Negative 4 is 4. Divided by 2 is 2. So that's my axis of symmetry. Yeah? So far, so good? Yeah. Then I move on to step 2. Find the vertex. Substitute the axis of symmetry into the problem. All right, so step 2. Y equals, instead of x, I'm putting 2 squared minus 4 times 2 minus 5. Is that right? Oh, where'd my graph go? There it is. What's 2 squared? 4. Minus 8. What's 4 minus 8? Minus 5. So my axis of symmetry is 2, negative 9. Yes? So 2, my vertex, sorry, yes. It's right there. Can that be reflected? Because it's on the axis of symmetry. I can't reflect it because it's there. Step 3, plot the y-intercept. It's the constant. What's my constant? Negative 5. So on my y-axis, I find negative 5. Four, choose an x value one space away from the axis of symmetry. Substitute into the original equation to get an ordered pair. All right, so one space away from the axis of symmetry. What are my choices? 1 or 3. Let's go with 1, right? I mean,
Do you want to do it on the same side as your separate?
doesn't matter. So y equals 1 squared minus 4 times 1 minus... I mean, you could pick any number. I'm just giving you a hint that this is the easiest way. Could you pick 15? Are you crazy?
Yes.
Yeah. All right, what's 1 squared? 1 times 1 is 1 minus 4, negative 3, minus 5. So 1 comma negative 8. 1 negative 8. I have 3 points, so I'm good to go. If I didn't have 3 points because it was already there, right? I'd have to fix it. Last step, reflect and connect. So this point is 2 spaces away. Boop, boop. So I'm going to go 2 spaces away. Boop, boop. This guy's 1 space away. Boop. I'm going to make it 1 space away. Boop. When you connect, how do you connect it? No straight lines artistically, right? That's graphing.